Greetings. So we are the group 6 and we are about to present our chosen topic or our chosen project. So entitled Real-Time Object Detection. But before that, let me introduce myself first. My name is Daniel Echeverry Tolentino from BSCS 3ABA. So next slide. Greetings. So we are the group 6 and we're about to present our chosen topic or our chosen project. So this is a real-time object detection. But before that, let me introduce myself first. My name is Daniel Echeverry Tolentino from BSCS 3ABA. So next slide. And I think that this might be the very first question. What is the real-time object detection? So in general manner, real-time object detection is a task of doing object detection in real time with fast inference while maintaining a base level of accuracy. So basically, literal siya na itong real-time object detection is magde-detect siya ng object. So once na nakapag-detect itong project na to ay nakapag-detect siya ng object, ma-identify niyo nito kung anong object na ito, kung anong object na yun yung na-detect niya. So of course that this specific project is really helpful, especially in this kind of generation, because this project could definitely help us to finish our task without putting so much time and effort, and will help us to identify object instantly. So the next slide would be presented by next.
And hello, my name is Eduardo D. Ubaldo Jr. And the next question is, what is the advantage of object detection? So object detection is completely interlinked with other similar computer vision techniques such as image segmentation and image recognition that assist us to understand and analyze the scenes in videos and image. So ang object detection ay ganap na magkakaugnay sa ibang katulad ng mga diskarte sa computer vision gaya ng image segmentation at na image recognition na tumutulong sa atin at maunawaan at suriin ng mga eksena sa mga video at larawan na kung saan ay maaring makapagproproseso ng impormasyon ng mas mabilis kaysa sa mga tao. So the next presenter is...
Hello, I am Russell Jason Santiago and I will discuss what this algorithm is best for real-time object detection. You only look once, or YOLO, is one of the popular algorithms in object detection used by researchers around the globe. According to the researchers at the Facebook, AI research the unified architecture of YOLO is extremely fast in manner.
Next slide.
So hello, I am Kate Aita Vargas. Now I am going to discuss the YOLO in object detection. So what is YOLO? YOLO is an algorithm that uses neural networks to provide real-time object detection. This algorithm is popular because of its speed and accuracy. It has been used in various applications to detect traffic signals, people, parking meters, and animals. Object detection is a computer vision phenomenon in which numerous items are detected in digital photos or movies. People, automobiles, chairs, stones, houses, and animals are among the items detected. So the term you only look once is abbreviated as YOLO. This is an algorithm for detecting and recognizing different items in a photograph in real time. So object detection in YOLO is done as regression problem, and the identified photos class probabilities are provided. For example, the car is surrounded by the pink bounding box while the white tail is surrounded by the yellow bounding box.
So hi, I am Franz RBB Tattao. So why the YOLO algorithm is important? So YOLO algorithm is important because of the following reasons. So first, speed. This algorithm improves the speed of detection because it can predict objects in real time. Second, high accuracy. YOLO is a predictive technique that provides accurate results with minimal background errors. Third, learning capabilities. The algorithm has excellent learning capabilities that enable it to learn the representation of objects and can apply them in object detection. So YOLO algorithm gives a much better performance on all the parameters. We discuss along with a high FPS for real-time usage. YOLO algorithm is an algorithm based on a regression. Instead of selecting the interesting part of an image, it predicts classes, and bounding boxes for the whole image in one run of the algorithm.
I am Julian C. Sarangay, and I will discuss the continuation on why YOLO algorithm is important. YOLO is a clever convolutional neural network for doing object detection in real time. The algorithm applies a single neural network to the full image and then divides the image into regions and predicts bounding boxes and probabilities for each region. It means to say that this algorithm trains on full images and directly optimizes detection performance and requires only a single forward propagation through a neural network to detect object. This also means that prediction in the entire image is done in a single algorithm run. Convolutional neural network is used to predict various class probabilities and bounding boxes simultaneously. Next.
So I'm Angelica C. Salveo. So how many objects can YOLO detect? So based on the COCO dataset or tinatawag nating common objects in context, YOLO can detect 80 objects classes. Those COCO classes includes things of which individual instances may be easily labeled. Person is the object that YOLO can easily detect. The other objects are in autonomous driving industry wherein YOLO algorithm can detect objects around cars such as vehicles like bicycles, motorbike, bus, truck, and others. Even parking signals and signs like parking meter, stop signs, and traffic light. YOLO can also detect various types of animals in forests or in wildlife. Some of the animals that can be detected are elephant, bear, zebra, giraffe, horse, and cow. Next.
Hello, so I'm Nico Quinto from BSCS 3ABA. In addition to that, I will discuss the challenges in object detection. So first is the viewpoint variation. One of the biggest difficulties of object detection is that an object viewed from different angles may look completely different. Next, the formation. The subject of computer vision analysis is not only a solid object but also bodies that can be deformed and change their shapes, which provides additional complexity for object detection. Occlusion. Sometimes objects can be obscured by other things, which makes it difficult to read the signs and identify these objects. Elimination conditions. Lighting has a very large influence on that definition of objects. The same objects will look different depending on the lighting conditions. Cluttered or textured background. Objects that need to be identified may blend into the background, making it difficult to identify them. Variety. The same object can have completely different shapes and sizes. Computer vision needs to do a lot of research to read an object and understand what it means. Speed. When it comes to video, detectors need to be trained to perform analysis in an ever-changing environment. It means that object detection algorithms must not only accurately classify important objects, but also be incredibly fast during prediction to be able to identify objects that are in motion. So that's all.
Good day, everyone. My name is Jeffrey Avisapla, and I am from BSCS 3ABA. Today, I'll demonstrate the OpenCV Python's real-time object detection. So let's start by determining the libraries are required for this project. As a result, we can see how immutable switches are utilized to construct a basic image processing. So this is a NumPy library NCV2 to read files that will be used in the system. So sa line na po ito ay gumamit po tayo ng YOLO algorithm, which is the YOLO V3 weights and the YOLO V3 configuration. And sa line naman na po ito ay dito po na-extract yung names, which is ang COCO files po natin. Pag na-extract po to, kunwari pag may na-detect po siyang object is magpapakita po doon yung name ng object na yun. And dito naman po sa video capture, ito po yung test video po natin. Which is sample video lang po yun. Then para po magamit mo po yung webcam mo para sa real-time object detection, is papalitan mo lang po siya ng 0. And dito na po lalabas yung name ng object, which is magpapakita pa kung ano po yung font ng object and yung color po ng box para sa object na na-detect mo. So, prepare the image called blob. cv2.dnn blob from image, then parameter. So, DNN or deep neural networks, this module lets you use a pre-trained neural networks from a popular framework like TensorFlow. First is input po natin yung image. Then the second parameter is the scaling and dividing the pixel into 255. Then the size of the image 416. So the set input is used to set input from the blob into the network. So in order to get all the information, we need the prediction from the bounding boxes or predictive classes. We also need to get the output layer name and then pass the names into the forward function, which will do the forward pass through the pre-trained models. So here we want you to get the name first by using the output layer names equal to net dot get unconnected out layers names function. Then layer outputs equal to net dot forward, then the function. So in other words, the net forward is used to run the forward pass and obtain their output at the output layer names, which we already provide them the layer names. So now the results and detections are all ready. However, we are not done yet because we want to visualize the result. We need to extract the bounding boxes and the confidence and the predicted classes, which will be stored into different lists. So we need to create a boxes list to extract the boxes list, to extract the bounding boxes. And we also need the confidence list to store the confidence. And we also need the classes ID to store the classes ID, which represent the predictive classes. And now let's listen to Mr. Salvador for more information and explanation on this project. Again, my name is Jeffrey Arisapla from BSCS 3ABA, presenting the OpenCV Python real-time object detection. Thank you.
So, hi guys, my name is John Daniel V. Salvador, and my part is to explain the rest of the code and do a simple demonstration on how the program will work. After what Jeff said, we have to create two for loops in order for us to extract the data that is stored in the layer outputs variable and assign the confidence and classes to the particular object. So makikita nyo gumawa tayo ng two for loops here in order for us to extract all the data sa layer outputs. So ang mga nasa layer outputs is yung detection scores, classes ID, and confidences. So after that, we will use an if statement to only save the object if the confidence score is greater than 0.5. If the condition is met, the boxes, confidence, and class ID will be stored in the list we have created. So, makita nyo gumawa tayo ng if statement here in order for us to get the width, height, x and y locations, and then we have to append those values sa boxes list na ginawa natin. So ito siya. So confidence na append natin. So nilagay natin siya yung confidence sa confidence list. Also the classes ID. So in-append natin siya. And then after that, we have to look over all the detected objects in order to put the boxes and labels into their corresponding objects. So makikita nyo gumawa tayo ng loop here to identify of each object detected, and then extract the information from boxes list. So ito yung boxes list natin. And then first index, we have to get the x and y width and height values there. And then the label from classes IDs. So yung classes IDs natin is for Coco file. So makikita sa Coco file natin yung lahat ng objects. So 80 objects yung nandun. So actually, pre-trained na kasi siya. So gumamit ng pre-trained. So hindi na tayo kailangan mag-train ng configuration. So, and then the confidence also will be extracted from the confidence list. So ito siya. So confidence list, yung ginawa natin kaninang confidence list. So it will extract using loops. So yung colors naman, nag-iterate tayo ng color kasi naggumawa tayo ng random color. So ito yung random color. So nag-iterate tayo ng color. And then yung color na ilalagay natin sa rectangle. So ito yung to create the rectangle. Ito yung create ng rectangle. So ang arguments niya is yung x and y values, yung x as width, y and height values. So yung color is ito. And then the width, ito yung width ng color, width ng line. So ito yung width ng line. So after that, we're also going to display the label and confidence in the top right left corner. So ito yung CV2 put text. So ito yung function na yun. Then we will input the label and confidence. We have kinoncatenate natin using a space here. And then where the font here, the Hershey plane, we have used yung ginawa natin kanina. So yung font size is 2 color and then the width of the color. So and then also created a failsafe here. Failsafe here, if key is equal to 27 and break. So if pinindot natin yung escape key, ito kasi yung 27, ito yung escape key. So pag pinindot natin yung mag-break yung program, then it will release the captured device. So ma-release na yung cap niya, and then it will destroy all the windows. So let's try a simple illustrate here. And then let's run the real-time object detector to see. So makikita nyo na-detect nyo yung person. So so makikita nyo ginamit natin yung extra camera ko for demonstration para mas malinaw. Makikita natin medyo mabagal siya dahil yung limitations namin is running for CPU pa lang po kasi siya, and we have to if we have time we can create faster models. So we can use increase the FPS speed of the detection or real-time object detection program and speed the process of detecting the objects. So let's try to use some objects here, example objects, and then try natin tong water bottle. So makikita niyo, i-detect niyo yung water bottle. And then try natin tong remote. May remote ako dito. Makikita niyo. Yan, remote. So makikita niyo gumagana yung natin, yung object detection, real-time object detection. So wala akong phone na iba pang gamit dito. For example, phone para madedetect niya pa rin yung mga ibang gamit. So yun lang yung aming real-time object detection program. So thank you for watching and have a good day.